Hello everybody! Today we are going to use division and the associative property to check and see if what the factors are for some larger numbers today. So just a quick reminder, the associative property. We did this last year, but we really haven't touched base on it this year, so just a quick reminder. The associative property states that if we're going to multiply, and this works for addition as well, but if we're going to multiply a set of numbers, more than two of them, it doesn't matter which order and which combinations of numbers we multiply first, we will end up with the same product. So for example, if I have something like 2 times 3 times 4, I can either solve this as 2 times 3, 6, times 4 to make 24, or I could choose to put my 3 times 4 first, get 12 multiplied by 2, still get 24. Or I could even rearrange all of my factors and do 2 times 4 first, times 3. That would equal 8 times 3, still equals 24. So it doesn't matter whether I do the 2 times 3 first, or the 3 times 4 first, or if I put the 2 and the 4 together first. As long as I multiply all three, I'm still going to come up with the same product. So that's just a quick reminder about the associative property. I'll leave that up here, but I'm going to make this really small so we have room to show our work, okay? So just a quick reminder about that. So let's take a look at something like 28, okay? And I want to know if certain numbers are factors of 28. So first of all, I want to know, is 7 a factor of 28? So I want you to figure that out. Is 7 a factor of 28? Pause the video if you need to. Welcome back. What did you find? Is 7 a factor of 28? Hopefully you said yes. And how do you know? Because you should know 7 times 4 equals 28, right? Maybe you skip counted by sevens to see how many of them it takes to get to 28, and if you hit 28, okay? Maybe you just know your facts, your 7 facts. So we know 7 is a factor of 28. What about 10? Is 10 a factor of 28? Pause the video if you need to. So is 10 a factor of 28? No, it's not. And we should know that because we know 10, 20, 30, we're not going to hit the number 28. Plus, we also know 10 is only a factor of numbers that end in 0. Okay, so if you have a number that does not end in 0, you automatically can rule out 10 as one of its factors. What about 5? Would 5 be a factor of 28? Once again, I hope you said no. We know that when we count by 5s, it's always going to end in a 5 or a 0. So therefore, 28 can't possibly have a factor of 5. How about a factor of 2? Again, I hope you said yes right away and you didn't have to skip count by 2s. Because any number that has a factor of 2 has to be an even number. So if your number you're looking at is an even number, you know automatically it's divisible by 2. So there are some numbers like 10 or factors, 10, 5, and 2, that you should be able to determine pretty quickly and easily if that is a factor of the given number you're looking at. But it's going to be a little harder when we're asking whether other numbers are factors, especially as we get to larger numbers. So for example, let's see, what if I asked you if 3 is a factor of 54? So we're looking at the number 54, and I'm wondering, is 3 a factor of 54? When you hear something like that, you should immediately think of it as a division problem. So can I divide 54 by 3? If I end up with a quotient that is a whole number, meaning I have no remainders, then 3 is a factor of 54 because it is easily and equally divisible by 3. So pause the video, go ahead and solve that, find out, is 54 divided by 3? You can use your place value chart, you can use an area model. I'm going to use an area model here. So I know I'm looking for a total of 54. So I know that I'm going to go with a 30 right away because I know 3 times 10 is 30. That leaves me 24 left, and I know 3 times 8 is 24. My quotient ends up being 18, so therefore I know that yes, 3 is indeed a factor of 54 because I ended up with a whole quotient and I did not have any remainders. What about 2? Is 2 a factor of 54? Hopefully you said yes automatically. How do you know? 54 is an even number, so we know it would be easily divisible by 2. How about 5? If you said no, you're right. 10? You're right. Nope. So let's take a look. Let's try another one. What if we have a larger number? Let's see. Actually, let's take a look at 54 still. We're going to think about 54, okay? And we already know that 2 and 3 are factors of 54, right? Well, what is 2 times 3? It's 6, right? So we know 2 times 3 is 6. Let's see if 6 is a factor of 54. 6 times what equals 54? Hopefully you guys are getting good at your multiplication facts. If not, go ahead, count by 6s, see if you get it. 6, 12, 18, 24, 30, 36, 42, 48, 54. Look at that. 6 times 9 is 54. Now we've determined that 6 is also a factor of 54. Here's what's really cool. If we already knew 2 and 3 are factors of 54, look at what this is. Isn't this really just saying 2 times 3 times 9 equals 54? Right? So if we know if we know 2 and 3 are factors of 54, both of them, then we know 6 would be a factor of 54. Okay? Because we know that we can fit 2 in there and we can fit 3 in there equally, so therefore we must be able to fit 6 in there as well. Okay? Let's see. What about if we look at the number 42, and we're going to use the same sort of strategy. Here we go, 42. First of all, let's see if 6 is a factor of 42, okay? So 6 times what is 42? If you said 7, good job. So 6 times 7 is 42. If 6 times 7 is 42, do you think 2 and 3 are also factors of 42? Well, if we know 6 is the same as 2 times 3 times 7, then you know that both 2 and 3 are factors of 42. But let's just check. Let's reorganize our parentheses. 2 times 3 times 7. What is 3 times 7? Well, it's 21. And what is 2 times 21? It's 42. So it does work. Okay? So now we've determined, because we knew 6 was a factor of 42, we also knew 2 and 3 were factors of 42. Let's take a look at one last one. What if I asked you about the number 72? And we're going to find the factors of 72. Okay? Think of the largest fact you know that makes 72. Hopefully you said 9 times 8 equals 72, which is true. Okay? So now let's try to break up one of those numbers into some smaller parts. Let's say we break up the 9. 3 times 3 equals 9, right? Times 8. So 3 must also be a factor of 72. So we automatically know 1 and 72 are factors. We know that 9 and 8 are factors. We've just also determined that 3 must be a factor because we can take the 9 and divide it up into 3 times 3. If we take a look at dividing the 8 up, I can split the 8 up into a 2 and a 4, can't I? So this would make it 9 times 2 times 4. So now we've also determined that what other two numbers are factors of 72? It's 2 and 4. Okay? So if I did, let's say, If I wanted to break up the 9 and, or do the 9 and the 2 first, that's 18. So now we also know that 18 is a factor because 18 times 4 is going to equal 72. If I rewrite my 9 times 2 times 4 and put the parentheses around the 2 times 4, I get back to my 9 times 8, right? I can also mix it up and do 9 times 4 times 2. 4 nines is 36, so 36 times 2 is another factor pair. So look at all the factor pairs you can come up with by using your associative property. I've figured out 32 and 6 is a factor pair you can use. 18 and 4 is a factor pair you can use. 9 and 8 is a factor pair you can use. Let's rearrange our 3 times 3 times 8. If I arrange this as 3 times 3 times 8, I know 3 times 8 is 24, so now I've determined that 3 times 24 is also a factor pair. So I've determined that I have factors of 1, 2, 3, 4, 8, 9, 18, 24, and 36 are all factors of 72, simply by taking a larger fact that I do know matches and breaking down one of my factors into smaller factors and rearranging them based on the associative property. So your job today is to answer some questions of whether a number is a factor of the larger number. Use the associative property, okay, to show me how you know. Good luck. Have fun.